In the module on sequences and series, we're first going to look at the quadratic number pattern. The general term t, the nth term, is an squared plus bn plus c, where a, b and c are parameters. So if you substitute n equal 1, the first term is a plus b plus c. If you substitute n equal to 2, then you get n times n, 2 times 2, 4a plus n is 2 plus 2b plus c. And if n is equal to 3, then the third term is 9a plus 3n plus c. If you substitute n equal to 4, then the fourth term is 16a plus 4n plus c. The first difference between the terms t2 minus t1 is 4a minus a is 3a, 2b minus b is plus b, and c minus c. And then the second term in the first difference, therefore t3 minus t2 is 5a plus b. There's a mistake there. That must be 3b. 3b, and that must be 4b. And then t4 minus t3 is 7a plus b. Now the second difference is 5a plus b minus 3a plus b, which is equal to 2a. And this second difference is 7a plus b minus 5a plus b, which is also equal to 2a. Therefore, the second difference is a constant and it's equal to 2a. So let's remind ourselves, in a quadratic number pattern, the properties, the second difference is constant, and in this case is always equal to 2a. And the first differences form a linear number pattern. The first term of the first differences is 3a plus b. The second term is 5a plus b, and the third term of the first differences is 7a plus b. And this is a linear number pattern. Now let's look at an example. In this example, the quadratic number pattern 3, 11, 21 and 33. We look at that number pattern. And you can see a plus b plus c is the first term, that's equal to 3. The first differences are 8, 10 and 12. And the first term of the first differences is 3a plus b, and the constant is 2, and that's equal to 2a. So let's determine the parameters a, b and c. 2a is therefore equal to 2 and a is equal to 1. 3a plus b is equal to 8, and now you know that a is 1, and you can determine the value of b, and b is equal to 8 minus 3, 5. A plus b plus c is the first term, equal to 3. You know a is 1, b is 5, and then you can determine what c is. 3 minus 6, so c is equal to minus 3. The nth term is therefore Tn is equal to an squared, so it's 1n squared, plus bn, 5n, plus c, in this case, minus 3. So that is the general term of this quadratic number pattern. Now it's easy to determine the term number 12. So if we look at question B, determine the value of T12. So n is now 12, so it's 12 times 12 plus 5 times 12 minus 3. It's equal to 144 plus 60 minus 3, and that's equal to 201. Each term in this pattern is equal to 497. So you know which term, so you need to determine n, and we know that the nth term, the general term, is 5n n squared plus 5n minus 3, and that's now equal to 497. To solve this quadratic equation, you write it in the standard form, equal to 0. Now you can either use the formula or you can factorize. If it's not easy to factorize, use your calculator and look at the factors of 500. But 20 times 25 is 500, and the middle term is plus 5n. So that's why you use plus 25 minus 20 to minus 20 times plus 25 is minus 500, and n times n. And if you look at the middle term, minus 20n plus 25n, that's plus 5n. Therefore, n is equal to 20, or n is equal to minus 25. But this is not applicable because n must be a positive value, and it cannot be a decimal, so it's a whole number, it's an integer. So in this case, term 20 is equal to 497.